Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of November, I'm going to be uploading 3 videos every day. 2 that are going to be average level difficulty and below, and 1 that's going to be average level difficulty or above. And this is today's average level difficulty puzzle, and it's called Dysprosium by Dorlier. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every region, which is a box for this one. Digits along marked diagonals sum to the number indicated outside the grid. So, for example, these digits along this diagonal would add up to 22. Same with these digits here, and same with these digits here. Right? Those will all add up to 22. These would add up to 33. These would add up to 33. And so would all of these. So it's pretty straightforward rule set. So it's a pretty straightforward rule set, and those are all the rules. It's an average level difficulty puzzle, so it's not going to be too hard, but it requires some thought. And if you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, straightforward, simple enough. 33 here, huh? So this has to be, if this is 17, this is 6, this is 17 at most, right? Okay, let's color in the diagonals. Maybe that's easier. We're going to make this blue. We're going to make this green. And we're going to make this pink. This is going to be yellow. We're going to make this red. And this could be orange. Okay, so there's some overlap here. Now we just have to look at the constraints, right? And the main constraints that seem to be are the 33s here. Both of these. This one particular, right? So if this is 15, so say it's 7 and 8, this would have to be 9 and 9 because it has to be add up to 18 at most. So this is at minimum 7 and 8. So it's 7, 8, or 9, or 8 and 9, or 7 and 9. If it's 8 and 9, that's 17. So 33 minus 17 is 16. So you can only have 7, 8, and 9 here too, right? So this would be 9 and 9 or 7, 8, and 9, right? Oh, in fact, we have very big limitations here, right? We have 3 digits here, we have 3 digits here, and we have 3 digits here. All of them must add up to 66. And we're given a 3, right? So if all of them must add up to 66, you could have 789, 789, and 389. That's the maximum. So that would be 24 times 2, which is 48, plus 3, which is 51, and then you have 66. So you could have 6 and 9, right? Or it could be 7 and 8. Right, if you have 7, 8, 9, 7, 8, 9. How many degrees of freedom? What's 3 plus 8 plus 9 is 20. 20 plus 48 is 68. So you have at minimum 2 degrees of freedom, 68 to 66. Yeah, 2 degrees of freedom. So this could be 5 through 9, right? You could have 5 plus 8 plus 9, which would be 22, plus 7 plus 8 plus 9, which would be 24. So it's 46 there, plus 3 plus 8 plus 9, which would be 66. So this could be anywhere from 5, 6, 7, 8, 9. This could be 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, right? Okay. Unfortunately, it doesn't tell us too much. Oh, we do have this limitation too. Yeah, this is an interesting limitation here too. Right? So we have on these 3 diagonals, these 6 must be on the line. These 6 must be on the line. These 3 must be on the line. These 3 must be on the line. These 3 must be on the line, right? So what's the max? Sorry, what's the minimum here? This is 1 through 6, so that's 21. This is 1 through 5 plus 7, which would be the so that's okay. So you have 21 plus 22. This is 1, 2, 3. This is 1, 2, 3. We know this is 7, 8, or 9 here. So okay, you have 21 plus 22, so that's 43. You have 1, 2, 3, 1, 2, 3, and then 1, 2, 7. So 43 plus 6 times 2. 6 times 2 is 12. 43 plus 12. Wait, does that work? Oh, 66. Yes, that does work. Wait, no, does it? Yes, that does work. Okay. Okay. That's interesting. Yeah, yeah. I think I see it. So say this was a 7 and this was a 7. That would be 14. And therefore these two would add up to 19. But that's not possible with 2 digits. Even if it's a 9 and a 9, that only adds up to 18. Therefore, this is 1 through 6 at the least. So that's 21. This is 1 through 5 and 7 at the least. So that's 22. So that's 43. This is 1 through 3 at the least. So that's 6. This is 1 through 3 at the least. So that's 12. So add 43 to 12. That's 55. And this has to be 1, 2, 8 if this is a 7. Right? Because then you could have 9, 9. So if this is 1, 2, 8, that would be 11. And you have 55 plus 11 is 66. So that's the thing. So therefore, we know this has to be a 5. We know this has to be a 5. Right? If it's anything more, or basically one of these two would have to be a 5 or a 6, but this is the only one that could be. Sorry. One of these two would have to be a 5. And there's only one that could be is that's a 5. So if that's a 5, we know this is 8 and 9. So this one has to be 8. This is 9. Therefore, this is 7. And this has to be an 8, 9 pair. This is also an 8, 9 pair, right? So this is 1 and 2. We know these are 1 and 2. This has to be 1 through 4. So this becomes 7, and this is 6. This is 1 through 6. So no 3. This can't be 2. This is 1, 2, or 3, so that can't be. So this has to be a 2. This can't be 2. This is 1 through 3. The 3's can't be there. Therefore, this is obviously 3. This can't be 1 or 2. This can't be 3. This is 1 or 2. No 3 here. This is not 1 or 3. So 3 is one of those two. Okay. So we figured that out. This is 33 also. So it's what? 3, 5. So 5 plus 3 plus 9 is 17. So this is 16. So this has to be 8 and 8. Which makes this 9 and 9. So this has to be 9. This has to be 7 and 8. Right? So the 9, 9, 18 plus 15. Yep, that works. Okay, so we can remove the red and yellows because those are done. And it makes it less confusing. 22 on the diagonal. Can this be 4, 5, 6? I don't think so, right? If it's this 4, 5, 6, it's 15. Yeah, it's already bigger than... So this has to have a 1. So this must be 1. This can't be 1 here. It could be 4, 5, or 4, 6. Or 5, 6 even, potentially. Adds up to 22, so we have 9 already, so that's 13 for the rest. So say it's 4, 5, which is the minimum. If it's 4, 5, which is the minimum, that's 10 total plus 18, so this would have to add up to 4. So this can never be 4, which means one of these is 4. Oh, wait, we got it. I don't know, it's a green. Never mind. Okay, so this is 4, 5, and 6. So 1 has to be here somewhere. This has to be 9. This has to be 8. 9, 9, or 8. We have 4, 5, 6, 7. Can't be 6 or 7. This can't be 5. Okay. So this is 4 through 8. This is 4 through 8. This is 4 through 8. We have 2, 4, 5, 6, 7. 2, 4, 5, 6, 7. 7 cannot be there, obviously. Okay, so this one's done. This one's done. There has to be a 1 here, so this can't be 1. Can this ever be 5, 6? If it's 5, 6, that adds up to 12. You have 8, but you cannot have 2 unique digits add up to less than 3. So it cannot be 5 and 6. So the 4 is always there. So this can't be 4. We know the 1 is always there. So it's either 4, 5 or 4, 6. And then it would be 1, 3 or 1, 2. So this is 1, 2, 1, 2. So this becomes 4, 5, 8, 9. Okay. Yeah, it could be, I guess. We know the 9 is one of these 3. Okay, this is 4, 5, 6, 7, 8, 9. This is 1 through 7. No 1, 2, no 2. We know the 4 cannot be any of these. So, could be 1, 2, 3. No, it can't be 1, 2. So That's 3. Can't be 4, 5, 6. This is 3, 5, 6. This is 3, 4, 5, 6. Oh, okay. So this is 4, which makes that 3. That makes that easy. So this is 1, which makes this 2, which makes that 1, that 2. This cannot be 2, so the 3 cannot be here. This is 3, 4, 5, 6. Okay, so this is 1 and 2, which means this has to be 4 and 6, right? Because, so this is adds up to 11. This has to add up to 11 also. So this is 4 and 6. So there is no 6 here. This is 2, 3, and 5. This is 4 and 6. This is 4 and 6. So this can't be 4 or 6. So this is 5. No 5s here. No 4s here. Okay, so the blue is essentially taken care of. So remove that. The green has to also add up to 22. So does the purple. Purple's probably easier because it's probably more limiting. So the purple is 2 plus 2 plus 3 plus 7. So the purple adds up to currently, without the other 4 digits, 14. Is that right? Two plus 3 plus 2 is 7. 7 plus 7 is 14. Yes, so 8. So we have a difference of 8. And therefore, this cannot be 3. If this is 3, this is at least 2, 3, and 1. So that would be 9. So this is not possible. So this has to be a 1, which makes this a 3. Can this ever be 5? I don't think so, right? If it's 5, okay, so we have 1 plus 2 plus, so it's 15. So 7 left. If this is 5, this would be 3 and 1. So this cannot be 5. So it's 2 or 3. Can it be 3? Probably. It just has to add up to 7, right? So if it's 3, 1 plus 2 plus 3 plus 3 plus 2 plus 3. So 1 plus 2 plus 7 is, we have 15. Plus 3 plus 3 plus 1. That works. This is 8 or 9 here. Interesting. Okay, so that's 8 and 9. What are the minimums for 33? Excuse my yawn. So right now the minimum here is 1 plus 4 plus 8, which is 13. This is 1 plus 4 plus 5, which is 10, right? So we tried 1 plus, okay, can it even be that way? Can this not be 1 is the question. It would be a question here, right? Actually, it has to be 1. Yeah, there's no other place for it. So this has to be 1. This is 1, so 4 and 8. If this is 4, this is 6, so that's 4. That's possible. Okay, minimum, this is 13. Minimum, this is 10. 10 plus 13 is 23. So this is at most 10. So this could never be 9. So this is 1 through 7 at most. So no 1, 3, or 4. No 3. So this could be 1, 2, 4, 6. This could be 1, 2, 4, 6. Huh. Right. Can this be 9? If that's the case, there should be 13 plus 14. 13 plus 14 is... Oh, wait, the 3... Oh, 3 could be here. Right. But 3 specifically cannot be... Oh. It can't be 1 plus 2 plus 3. Because 3 eliminates here, here, and here. So this is 1, 2, 4 at most. So this cannot be 9 either, right? If it's 1, 4, 9, that's 14, plus 1, 4, 8, that's 13. So 1, 4, 9 here, 1, 4, 8 here. So 14 plus 13 is 27, but you can no longer have 1, 2, and 3, so this can't be 6, which would be needed to add up to 33. So this cannot be 9, which means we know the 9 is here. So that's 9. There's only one place for 8 now, so the 8 has to be here. So we know the 9, this is 1, 2, and 9. Oops. This is 1, 2, and 9. So no 2, no 1. This is 3, 6, and 7, which means no 6, 7, no 3. So this is 4, this is 3, this is 5, this is 2, this is 3, this is 5. So that tells us quite a decent amount, actually. No 5 here, no 5 here, no 3 here. So what is, yeah, we know, we have pink then. So it's 1, 2, 3, 6, 3, 2, 11, 3, 7. Wait. 21, yes. And therefore this is 1. So this is 2. That should add up to 10, 22. Yes. So all the greens are done. Oops. So, and all the pinks are done. So no 1, no 2, no 2, no 2. So we have 2, 5, 6, 7, 8. 2, 5, 6, 7, 8. Okay, this still could be 1, 4, and 5. So we know 9 is one of those. 9 is one of those 3. We have 1, 4, 6. This is 1, 4, 6. This is 4, 6. So these cannot be 1, 4, 6. So this is 3, 9. Interesting. So, this could be 4. Can it be 1? It could be 1, technically. 4, 5, 6, 7. And it could be 2. Can't be 2, right? 1, 4, 5, 6, 7. This is 1. This is 2. No 3. 2, 4, 5, 6, 7, 8. No 8. Oh, 8 is one of these 2. Doesn't tell us much. Okay, so how does it interact is the question, right? So far, this is minimum 10, minimum 12. Wait, minimum 10 and 12. It could be 8, but this can't be 8. These could be 8. This still has to be 8? I think I made a bad assumption there. I calculated it wrong. Oh, no, 13. 13. No, I'm right. I'm right. So this is 13 at minimum. This is 10. So this is 10 maximum. You can no longer have 2, 3, and 5. So the 1 has to be, I think, on this diagonal. Right? You can't have 2, 3, 5, which is the only other way to add up to 10. Yeah, you need 2 and 3 to add up to 10 or less without a 1. So the 1 has to be there. So this can't be a 1. Oh, there's no 5 or 6. So no 6, no 5, 6, no 5, 6, no 5, 6. It can no longer be 1, 2, and 7. If this is 1, 2, and 7, this becomes a 4 and a 4, which is not possible. So 7 is not possible here. Could be 1, 2, 6, could be 1, 2, 5, it could be 1, 2, 4, could even be 1, 4, 5, I think. Right? Say it's 1, 4, 5, then you have another 1, 4, 5 and a 1, 4, 8, and that adds up to 33. So that could be the case. It cannot be 1, 4, and 6 though. I guess this could be 2, 1, and 6, so that's possible. Okay, so how many degrees of freedom do we have? 148 plus 145 is 10, plus 124 is 7. So we have 13 plus 7. So we have 3 degrees of freedom. So 4 could go up to a 7. That works. 4 could go up to a 6. 8 could go up to 9. And then 4 could go up to 6 or 5. Fine. 2 could go up to 5. Fine. Okay. We just have to calculate these out then, or just basically figure out what's what, right? Okay, let's remove the orange diagonal because we want to do distinct numbers here. So we're going to make this green and this blue. So this has to be green, which means the green is one of these. The blue is one of those. Not sure that tells us very much. This cannot be green. Say this was the blue, right? If this was the blue, and it was 6. Oh. Okay, I see something. This cannot be 1, 2, 4, obviously, because then this becomes 7, 7. But we know to add up to something that's 10 or less, you have to have a 1 or you have to have a 1, first of all, because there's no 3 involved anymore. But then you have to have a 2 or 4. And this is 2 or 4. So the 7 has to be here, which means these can't be 7. And this cannot be 2, because either this is 1 or 2, this is 2 or this is 2 or 4. So one of those two cases has to be the case. So this cannot be 2 or 4. So the 7's here, which means this is this can't be 7. Okay, so say this was 6, right? That removes 2 degrees of freedom. So this is 4. This would have to be 6. Oh, that's not possible. Right? This can no longer be 4. If this is 6, this can no longer be 4. So that removes the degrees of freedom. So that would remove 2 plus 2 degrees of freedom. So that would be 4 degrees of freedom when we only have 3. Degrees of freedom is basically just like what, how much you can change each digit and still add up to the same value, right? And that's what we define that by getting the minimums here, right? So we have from the minimum the degree of freedom possible. And so this one cannot be 6 because of that, right? Because if this is 4, this becomes 6, and that cannot be, sorry, if this is 6, this becomes 4, and then this can't be 6 anymore. This can't be 4 anymore. So that wouldn't work. Similarly, this can't be 6 too, right? Well, maybe. Actually, maybe it could work. Say this was 6. This would be 4. This would be 5. So that removes all our degrees of freedom. So this would be 6. This would be 4, 7, 6, 4, 1. But that would force this to be 6. Which gives us more degrees of freedom possible. So that's not possible. So this can't be 6 either. Can it be 7? Oh, one thing we know is this can't be 4. Yeah, it flat out can't be 4. If this is 4, this becomes 5, and that becomes 7. And we've lost all our degrees of freedom. I mean, sorry, we exceeded all our degrees of freedom. That's more important. Right? Because we lost 1 here, and we lost 3 here, but we only have 3 degrees of freedom. So that would be 4 degrees of freedom lost. So this cannot be 4. So we know the green is a 6. So this is a 4. This is a 6. So the green is here, so it has to be 6. This can't be 6, this can't be 4, so 4 is one of those two. Okay, so we're going to remove the green because that's not helpful. The blue isn't very helpful either. So this can't be 4, this can't be 6. If this is 5, this is 7, this is 8, that's 7, 6. Oh. We have 5, 6, 7. We have a 5, 6, 7 triple where only 5, 6, or 7 can be in those 3 squares. Therefore, there's no 5, 6, or 7 in any of these squares. Therefore, this is 4, this is 3. So this can't be 4. We still have 1 degree of freedom here, 3 potentially here, and then 3 potentially here. So say we used it all up. This would be 7. That would be 2. This would be 4, 6, 7. So the 2 would have to be here. This would have to be 1, but this would have to be 4, which is not possible. So this cannot be 7. So this has to be 4, which makes that 7. Makes that 6, this 4, 1. This is 2, this is 7. This has to be a 6, which gives us 1, 2, and 6. It cannot be 4 anymore. So that's the 1. It cannot be 4. So that's 2. That makes this 7, this 9, 3, 9, 2, 1. So I think all the 1s are taken care of. All the 2s should be taken care of. All the 3s are taken care of now. The 4s, not yet. Oh, but this is 4. 7. Yeah, it's still not there. No 9, no 9, no 9. So this has to be the 9. Which makes this 8 and that 9. And I think that adds up. This is 14. 14 plus 10 is 34 plus 9, which is 621. It's 33. Yep. And this is 5. This is 6. This is 7. This is 5. 8, 7, 6, 5. 4, 8, 5, 8, 5, 4, 7, 6, and 8. And that's the solution. Not too bad. Yeah, average level difficulty seemed about right. And yeah, I mean, one thing about these diagonal rule lines is that you can get some nice logic here, like especially like saying, oh, what are the minimum values here? What are the minimum values here? And then basically figuring out what your degrees of freedom are from that. And you have also the same thing here, but with what are your maximums, right? So you had what are the maximum in this 3 set, what's the maximum in this 3 set, what's the maximum in this 3 set. And then you combine that with the minimums here, and that's how you solve the puzzle. I can't speak right now. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.